Hi guys, you're welcome to another tutorial. Today we're going to be looking at a problem on finding first and last position of elements in an array, in a sorted array. So let's look at an example. Given an array of integers numbers that are sorted in ascending order, so we have idea of the structure of this array, that the elements are sorted in ascending order, and that gives us an intuition into what we can do. It's a find the starting and ending position of a given target value, and we are constrained to have our time complexity to be in the order of log n. And if the target is not found, you should return this um, -1 For example, let's say we're given this array 5 7 7 8 8 10 10, and the target is 8. So our output is supposed to return the starting position of our target value, and if you can check, if you look here, you see that the starting position is 3, because this is 0 index, 1 2 3. So it's starting at 3, and you see here that it is ending at 4. Alright, so that is what we want to achieve. Let's say, for instance, let me give an example. Let's say, for instance, we have an array where we have 1 and 3, and our target is 3. So what do you expect that algorithm should, or program should return? You expect that it should return 1, because it's starting at 1 and it's ending at 1. Alright, so you get the idea. But if we say the target is 1, you expect it to return what? 0 0, because it's starting at 0 and it's also ending at 0. So that's the idea of this program. So I'm going to walk through how this can be implemented in Java. If we are not restricted by the time complexity, there's an approach where we can go about this, but it's not going to take us log n. It's probably going to take us a linear time. Because first we will need to search through the array. For instance, we search through the array. That means we are going to have two variables, I and j. So our I is going to start here at the first index, and our j is going to start at the last index. So the first thing we do is that we increment our high until we find the first occurrence of our target. So once we are able to locate the first occurrence of our target, then we are sure that there must be a last occurrence. That means there must be the last index, the ending index, which may actually be the same as the starting index. So once we increment our I, and our I is able to locate the first occurrence, then we decrement our j, and our j will stop when it locates the first occurrence from behind, from the back. And if you look at that, in the worst case will be when the target is actually not present, or is actually at the last position. So if our target is at the last position, then our I we have to run from here up to the last element. So in the worst case, we might have to run through the entire element of our array, which will be in the big O of n, where n is the number of elements in our array. So you can try to implement that, but that is going to take us a time complexity of n. Now let's go by this and see the implementation, because they have given us that we should implement it in logarithm complexity. That tells us that the only way we can get a logarithm is a form of binary search approach, which means we have to keep dividing our array into equal amount at every point of iteration. That's the only way we can have a logarithm time complexity. So let's see the implementation in Java. Now this is our method. It's supposed to return an array of int, and it's taking an array of int, and at the same time it's taking a target, which is an int. So first we declare our array boundaries. Low to 0 and I is the length of our array. Now we have some utility variables there. In case when we get a solution reached, we turn this to true. But now we don't have a solution, so it's a false. Now we declare a solution inside these two variables, left and right. Since the question asks us to return -1 and -1, array of -1 and -1 if there is no solution, so we declare left and right as -1 and -1, and so this shows that there is no solution. So in our code routine, we're going to update the values of this left and right when we are able to get a solution. So that's the idea. So initially we assume that there is no solution, then in our code routine, when we're able to get the solution, we update these values. So for us to achieve a logarithm time complexity, we need to divide the array into two parts, and each of the iteration we divide it into two parts. We check low whether it's less than or equals to I. So whether it's less than or equals to I, and make sure that we don't have a solution, because this is false, not false will give us true. So because low is less than or equals to I, this is true and this is also true. It enters into this while loop. Now we add the low to I and divide by 2, then this will be truncated, and we take the floor and we give our middle as that value. You can do a test to print out that middle to check. Now we reach a solution area if middle is equal to target. That is the intuition behind this. For instance, if you go back, if you divide this into two parts, let's say your middle gives you 8. The value of your middle index is 8. Then you know that is either you have 8 in front or 8 behind, or just only 8. Alright, so that tells you that you're already at the solution area. That's the idea behind it. If your middle gives you 5, that tells you that you're already at the solution area where your target is, if your target is 5. So you discover that you're already at that solution area. So you just need to check behind and in front to be able to capture your starting and your ending index. So that's the idea behind this. So if our middle gets, we check the element at the middle. If it's equals to our target, then we can spread to left and right to get our starting and ending index. So that's why we put solution reached here to be true. So now we have this variable in left index equals to 0, and what we do is we check why the middle index minus 0. This technically is just checking the middle in itself because it's rechecking the middle, and there's a reason for that, in case it's just one element, so that we will not forget that middle. So it's checking middle minus left index is 0. Is it equal to our target? Of course, which is the same thing that brought us into this it's the same thing that brought us into this this if condition. So we're just retesting this if body, because that is because this was true. That's why we enter into this body of the if. So we're just retesting the same thing here. Now what do? We update our left solution, the value of our left, with middle minus that left index, which is 0 here. So whatever our middle is now becomes the value of our left index. That is our starting index for now. Then we update this left index by 1. What are we trying to do? We want to go behind, just one step behind with the middle. We go one step behind the middle to go and check whether again we still have a repetition of that target before the middle. Okay, but we do a check here. If we subtract that increment from the middle and we discover that the value is less than 0, we need to stop, because that means we have reached the edge of our array. For example, if the middle is giving us 0 and our left index is 1, by the time it's 0 minus 1, then we're going to have minus 1, which is less than 0. So we need to break out of this while loop and just return what we have as our left. If not, so we keep doing this again. We keep doing this. We subtract, we come back to this list, our left index, we subtract from the middle. If it is the same target, then again we update our left to the new value, which is our left solution. We increment index again, left indices, we increment that. We go back again and check if it is still the same. So this while loop is going to exit when this is no longer satisfied. So when the value of middle minus left index is not equals to target, that means we have already exhausted the repetition. So we break out of that loop. Or if we have reached the edge, that means that left index is the starting, it has reached the starting position. If we reach the edge, we break out. So this is very core in understanding what's happening in this program. So if you understand that, it's the same intuition that we have for the right hand side also. We put right indices to be 0. We also check whether norms middle plus right index is equal to the target. In this case, we are not subtracting, we are adding, because we want to check to our right. So we're checking to our right, and we keep updating our right indices. So the first time, just like we did for the left, it's just a repetition here. And if we see that middle plus right index is greater than I minus 1, this is very important. because if you put I, then you're going to have array index band of error here. You need to have I minus 1. If you check, because it's going to get to a time that, because your I, let's say the number of elements in your array is 4, okay, so your I is going to be 4, but then your index should stop at 3. Your index should stop at 3. So that is why we need to subtract minus 1 from here, so that it will stop when it is equals to 3. When it is equals to 3, because when this one becomes middle plus I is 3 and your I is 4, then it's still going to go again. Then 4 is it greater than 4, and 4 is not greater, so it's going to go again, and then you are going to run into array index cut of error. So you need to subtract 1 from it so that it will stop at exactly index of 3, so that when this one becomes 4 is greater than 3, then it's going to break. So you need to understand this. This is very important. So now that is the first part that we have. If we have our, you check here, this is where we're starting our if condition. So if the middle element is equal to the target, we do all those that we have just gone through, the 2 while loop for left and right. Else if the middle element is not equals to the target, then it's either it is less than the target or it is greater than the target. Now this is now where the knowledge of our sorted array comes in here. If we know that the array is sorted and we compare our middle element to the target, so if our middle element is less than the target, then that is telling us that the values, the target we are looking for, will be on the right side, because our array is sorted in increasing order. So that means we have not gotten to where the target is yet, because the middle is still less than the target. That means the target will be on the right side. So because the target is on the right side, then we shift our low to right to move towards where the area of the target. So the boundary of our low now moves from low now becomes middle plus 1. We don't need to check middle because that has been taken care of with the first if. So it becomes middle plus 1. I want to be sure we understand that. It's very important that we understand that. Let me try and demonstrate that here. So this is what I have. Let's say I have this line here, and here is my middle. This is my middle, and let's say my middle value is 4. So if my middle value is 4 and this is 0 and this is 10, so if my target is 7, then 7 is going to be within this area. So there is no need for me to look at this area anymore. So my 7 is going to be here. But if my target is greater than, if my middle element here now is greater than my target, let's say my target is 3, then I don't need to look at this side. I need to bother at this side in my next iteration. So that is the idea with that. That's the idea with that. So that is exactly what we do for this part and for the other part. If we see that the middle is greater than the target, we just what? We just shift our I. The I now shifts down towards the low part because the middle is less than that. So we check the lower part, and that's just it. So you can go through the code in my GitHub page, and the time and space complexity. Time complexity is big O of log n, but the space complexity is just constant space. The space complexity is constant space because we are not using any extra space. We are not our space is not growing, so we just have a constant space. Thanks for listening. Your comment are highly appreciated. I will just do a quick demonstration of the code that is posted on GitHub. So this is the full implementation. So let's say, for instance, you have this implementation. You have this 3 3 1 and your target is 3. So what do? You expect that it's going to return the starting index is what is 1 and the ending index is 2. So let's see that. So you can just demonstrate that here. So just do a demonstration of that. So this is just a demonstration of that here. So we have a Java, then we have a Java. So you can see the result here. That is just 1 2. So and if you decide to test this other one that we have here, let's say you want to test this one, let's say we want to test 7. So we want to test 7. What are we going to have is 0 1 2 3. So we expect it to give us 2 3, and let's see that. So we can just run that Java and Java. What's it giving us? This is 2 2 2. What's going on there? Possibly some error there, but fix that up. Thanks for listening, and see you in the next tutorial.